Okay, we're ready to go. So good afternoon, everybody. My name is Paul Andrew, and I'm a program manager in Office 365, and my focus is on performance management and networking connectivity for enterprise customers. This session is called Get Your Enterprise Network Ready for Office 365. I'm joined by Paul Collins.
Hi everyone. I'm Paul College. I'm a senior program manager also with the Office 365 team, and I spend my time looking after network connectivity, network performance to the service.
So today we're going to be talking about enterprise customer connectivity to Office 365. We're going to talk about some of the principles that we have established to help customers to think about how to establish that connectivity and how to plan for that connectivity and how to implement so that it works really well for them. We're going to talk a little bit about bandwidth planning for that connectivity. We're going to talk about comparing and contrasting use of proxy servers, direct network connectivity, and ExpressRoute. So it's going to be a wild ride. We have 75 minutes, so we'll get right into it. So first up, I want to talk about what is enterprise connectivity, because the thing is, much of what we're going to talk about today doesn't apply to small businesses connecting to Office 365. And the reason it doesn't apply to small businesses is connectivity in a single Office business is usually really simple. And it's those really simple networking connectivity situations that we don't have to give this advice for, and we don't have to work through all this planning and think about how we're doing it. Typically what you see is a Wi-Fi router, maybe a firewall, hopefully a firewall, and then an ISP connection onto the internet, and that's all you've got. And you're going to get really quickly onto Microsoft's network, which is one of the largest networks in the world, covers a large number of countries around the world, and connectivity and performance on that network is as good as we can make it. So for small businesses, users in the same building, this is pretty straightforward. What we want to talk about is connectivity for enterprise customers who typically have a WAN environment connecting all of their own offices and all of the different environments they have. Often this WAN is global in nature, and it was built originally to connect up users to in-house servers, all of those applications that run on servers that people have built over time and house in their operations facilities, in their own data centers. So let's take a quick look at how we've got this in the diagram here. The consumer last mile connecting onto the internet, and then the first mile, as we like to call it as Microsoft employees, the first mile is the mile away from our data centers, which really we're talking about the expanse of Microsoft's network worldwide. So that consumer last mile or that small business last mile is just their connectivity onto the internet and then onto that peering with Microsoft's network. As compared to an enterprise customer where they've got multiple offices, you can see an example here in Seattle, Paris, and Sydney, and then in that head office where they've put their data centers and all those application workloads, this is typically where the internet connection is first established by that company. So if you think back over time, this is historically how people first connected to the internet. They had these WANs, and then they allowed people to use the internet in small amounts over this single connection with these two red firewalls you can see there on the diagram. It's important to have those firewalls. So we have this, and now we want to implement SaaS networking on top of that. And that's what we want to talk about today, is how does connectivity to SaaS networking impact the philosophy and the ideas behind internet connectivity that enterprise customers have already had. And you can see my friends here traveling in Asia down the bottom of the diagram, and maybe they're connecting on a VPN onto the corporate WAN. So they've got to connect from wherever they are in a hotel onto the internet, onto their corporate WAN using a VPN, out through the internet connection for their corporate environment, across the internet, and then they get onto Microsoft's network. They're going to hit our front-end server and connect to Office 365. That sounds like a long way, and we want to talk about strategies for working through this situation. So when we think about what has led us here, it's always important to talk about the changes that we're making, because many times a lot of the people that we work with day to day who are managing these systems are not experiencing these big changes that we see in the networking world due to SaaS. The shift of moving from data centers on premises to data centers in SaaS is simple to say, but actually what it means is now all of that huge amount of data that you used to have on premises and being hosted by the company and running on whatever high-speed network you have inside your company is now out on the internet, or should I say it's being hosted by Microsoft in Microsoft's data centers on behalf of the customers. Now, that means all of the network traffic that used to be invisible to this internet connection and the security inspection is now going over that same internet connection that you have. This is a huge change. And at the same time, we're seeing more and more security exploits and problems with networking that have to be dealt with. And it's becoming more apparent that security at the edge of a network, of a WAN, at that internet egress point, is necessary. It absolutely has to be there, but it's not sufficient to protect people against some of the security intrusions that we're seeing today. We're seeing a lot of things started by phishing attacks, spear phishing, emails coming in, people getting phone calls, this kind of stuff. It's not enough just to have that perimeter network. So more and more people are thinking about, how do I secure the client machine? How do I secure the user? How do I secure the data? It's not just that network perimeter, which historically has been where all of that focus is. The next trend I want to talk about, the change that's been happening, is the growth in network devices that people are using. And this is really driven by the security issues that we're seeing in the ecosystem today, that people are looking for ways of addressing these security issues, buying more equipment that can help them with specific risks that they see. And we're seeing new technologies come as a result of this. We're seeing a lot of growth in this market and a lot of money being spent on devices in this space. So this is a change. And then a further change is some of these networking devices are explicitly moving to the cloud as well. Just as we see the workloads for compute move to the cloud, we're seeing the workloads for networking move to the cloud. And what I mean by this is some of these networking security devices are being hosted in infrastructure hosting services. I don't mean that the cables are moving into the cloud. That would be crazy. But a lot of these networking stacks are literally no longer in organizations' head offices. They are being hosted around the world in IaaS hosting locations. Okay, so in response to these and to help our customers to connect better to Office 365, we've been working on what are some good ways to establish connectivity to Office 365, taking into account all of these things that are going on with enterprise networking today and all of these changes. And so we've worked with the team that Paul and I are on, and a number of other people have been working directly with large enterprise customers. We have a lot of them in Office 365, and it's only growing. But we've taken experience from listening to what their needs are and what they have to say, talking to them about some of the changes that we'd like to see to improve connectivity to Office 365. And we've come up with a set of 4 principles that we want to share with you today and talk through. If you think about these principles and use them in your planning, you'll end up with great connectivity to Office 365 and a good environment in terms of performance, availability, and end-user experience for your users on Office 365 workloads. So the first of these is about identifying Office 365 network traffic. And just as we have SharePoint on premises and Exchange on premises that we used previously, where all of that traffic would go from the users directly to those servers, and we have separation of that traffic and internet traffic for recreational browsing or accessing consumer sites that are unknown to the organization and may or may not be part of the daily operations of their business. We want to separate those 2 types of traffic when you're connecting on the internet as well. So we have published all of the endpoints for Office 365. We have URLs and IP addresses for Office 365 at this convenient URL, aka.ms/o365IP. And so the Office 365 administrator can go and fetch these and then deploy them onto their network device, their firewall, to allow connectivity for their users through that firewall in an expedited or optimized manner. So we're looking to optimize the traffic for Office 365 and get better connectivity for that traffic, where it's traffic that's connecting to Microsoft data centers, it's encrypted traffic, it's secured, and so we're going to talk throughout this session about differences in processes that need to happen on that traffic compared to recreational, untrusted browsing traffic. All right, so we have an XML file that we publish that includes all of this information, so you can download that and use that for automation. We also have an RSS feed, which is available for picking up changes. In general, we have changes to this about every month. We have new URLs or changed IP addresses about every month. And we publish those monthly, and we provide a 30-day notice period. So we publish new IP addresses, and there should be 30 days between that publishing and when servers behind those IP addresses go live. So when you see them in the RSS feed, you've got about a month to make sure that firewalls are open, that connectivity is optimized, and that you have that connection through for those new servers. Now, a common question that we get here is, why do you change the URLs and IP addresses all the time? And so this is where a cloud service differs to what you might run on premises. Whereas we are not your outsourcing provider. We're running a SaaS service which is growing all the time. We got to keep adding hard drives to that SaaS servers, which means IP addresses. We've got to keep adding new data centers. We're going to keep doing that all the time. We've got to keep adding features that customers are demanding. And so all of those things mean that there are always going to be new address spaces coming along. And we're working to optimize those and reduce those and vet those as well. But that change is an inherent part of using a SaaS service. And so the discussion is about how to manage that and how to understand that. As part of understanding those URLs, we have an HTML page that accompanies these that details what are the different areas of endpoints that we have. So there's lots of great detail there. So we've got an XML feed for automating your systems. We've got RSS for change management. And we've got HTML for guidance and documentation around those. We're working on how we can better automate publication of these, and so it's a great time to get feedback about those as well. So expect improvements to come there in the future. I think we'll talk a little bit more about that later in the talk. So the second principle is local internet egress. And this second principle is really around getting out of that corporate network as fast as possible and then getting connected onto Microsoft's network. So here's a traditional network. We've got a corporate WAN with our 2 red firewalls, and that's the only place where internet connectivity is available. So our recommendation is to have connectivity at each office or each user location that allows Office 365 traffic to get out onto the internet and then onto Microsoft's network. Remember 2 things that drive this. One is Microsoft's network is global and one of the largest 2 networks in the world, so it's likely to be close. And that means that we can put front-end servers really close to your locations because we're on that network and we have those locations available. The other is that all of our traffic is encrypted, and it's traffic that you should have heard about already in your discussions with onboarding to Office 365. Lots of customers do due diligence about this traffic and learn about it and what they're connecting to before signing up. So take advantage of that, egress it early. Now, the way my diagram looks, it looks like you should do this at every single building you have. And sometimes I work with customers and they have thousands of offices all around the world. And they're looking at these and trying to tot up how much money all these racks of servers is going to cost. So sometimes this can be difficult, and our guidance is in close proximity to the users. Maybe that's not in the same building, maybe that's in the same city, or at least in the same geographic location. What we want to see is not a single egress point at one point in the world, and then you're going to be connecting to our front-end servers there, but where is the data, where are the services running, and what about that long distance of networking connectivity inside the corporate WAN? That's going to be impacting your performance and reliability of the service. So as close to the user proximity as you can is ideal, but understanding that that may not be all in the same buildings as users. There's a few different ways of achieving this. Obviously now what we've got is we've got two networks going out of a particular building. So we've got a routing choice to make there, and that implies that you've got some equipment which is pulling down at least Office 365 IPs and URLs to make that choice, but probably some other equipment there as well that you're looking at. The other thing to ensure that you're doing with this local egress is, and wherever you're doing this local egress, also do DNS lookups at the same location. Now, this is key because DNS is one of the mechanisms that Office 365 uses to identify where the users are around the world. We'll help direct those users to the front-end server in Office 365, which is closest to them based on where their local DNS server is. And so you want that local DNS server to represent the user's location. If you're going to do local egress, but you still have DNS lookup only in one location in the world, that doesn't help you because your connectivity from the user goes out the local egress to the front-end server at that location where you've done DNS lookup that we think your user is. So your connectivity's got to go across the internet all the way over there, and then you'll find a Microsoft front-end server for Office 365 that we can connect you to. Now, we do this primarily, this mechanism primarily in Exchange Online, but it's possible that this will be used in other workloads at points in time, so it's important to make sure that that DNS lookup aligns. And we're talking about the local DNS server, or the DNS server that actually does lookups to authoritative name servers. It's got to resolve the name servers and look up those URLs in order to do this. There's another type of DNS server commonly used, which is a forwarding DNS server. And a forwarding DNS server, it's simple to set up, and what it does is it forwards all requests to another DNS server, which may be a forwarding DNS server or maybe a local DNS server that does those lookups. So your job is to know where the local DNS servers are for your organization that do those lookups. As long as you know where they are and you're confident that they're secure and they're close enough to where your users are, then you're in a good place. If you don't know where they are, or you happen to know it's in one location in the world, you probably have some work that could really easily improve the performance of Office 365. All right, so number three, principle number three, is about avoiding network hairpins. And this really follows on from principle number two, because principle number two for local egress helps you to avoid a specific network hairpin. But we break out this idea of network hairpins because there's another way that this can happen, and it's a little more complicated to see these. Really what you're looking for is we want a straight line path from the client to the front-end server to the back-end server where the user has to connect to and get their data from. So in order to get that straight line path, the ideal is a piece of fiber optic cable that comes out of the back of the user's PC and goes straight to our front-end server. The opposite of the ideal is to connect all the way around the world and then all the way back, because that's going to be a long way, right? So if you have to connect all across the enterprise WAN to a single point of egress to the internet, that's going to create some kind of hairpin. It's going to create this long leg, potentially, in a worst case, if you have DNS local egress and network at a single location, say the other side of the world, then your user is going to be directed back to where your traffic's going to be connected back to where the user is in order to connect to that front-end server, even though their internet egress is a long way away. So we want to avoid that. We want to also avoid this kind of hairpin where you are using a network device which has moved to the cloud, but it's only available in a single location or a small number of locations. And what you end up doing is here's another hairpin where you connect from the user or from the organization out to this third-party cloud, back onto the location where the Office 365 Edge server is. And so really all we're doing here, a first principles explanation, is we want to identify how long is that network path between our user and the front-end server that's on Microsoft's network. And these two examples of hairpins are examples where you can add a lot of latency into that connectivity that you can fix really easily with some intelligent routing choices. So our recommendation here is to reduce the latency that's caused by hairpin networks. You know, you don't have to go crazy. It's not about looking at the every millisecond has to get off my network. It's about removing those 100 millisecond legs, which are going to adversely impact user experience. The minimum requirement here is really to look for something that is causing your user's network traffic to go from one continent to another. So if your user's traffic is going from Australia to North America, this is a long way. We got something in the order of 150 milliseconds of latency to get across the Pacific Ocean, and you should be able to avoid that. We've got front-end servers in Australia. We've got the Microsoft network in Australia. So get users egressed off that network, avoid those hairpins, get them onto those front-end servers in Australia. This makes an incredible amount of performance improvement, even if that user's data happens to be in another continent. We can take care of that on the back end with optimizations between our front-end servers and our back-end servers, and we can significantly improve the user's performance with those front-end servers. So this is about getting your user's connectivity onto those front-end servers. And in the back end, you can rely on us to be improving connectivity between our front-end servers and our network and our back-end servers and everything in between. That's the job we have engineers back in Redmond working on. So then there's the enterprise hairpin that you sometimes see where people have user through enterprise WAN to remote internet connectivity point back over to where the user is because of the that DNS lookup. And the third-party cloud hairpin that you might see if you're using a network as a service provider for some kind of networking device and it is in an infrastructure service that is just too far away. Your job, of course, is figuring out how far is too far away, but generally in our experience, if something is in a different continent, it's too far away. And then it's up to how is this impacting your users. Certainly if something is impacting your users, it's probably too far away, or there's another problem that you've got to troubleshoot, right? But anyway, so number 4. So our principle number 4 is looking at enterprise network connectivity and the inherent security devices that are necessary for connections onto untrusted internet sites that users on this enterprise might want to connect to. So we got a whole lot of different examples of devices here that may be on that perimeter, that network perimeter that is used for connecting from a user's PC onto the public internet. And really what we're looking at here is the change between users connecting to on-premises servers for Exchange and SharePoint and whatever other system you might have that has your workloads and your corporate data in, and the change from that to connecting to that same data and those same workloads over the internet where the company already has an internet pipe. They've already got an internet pipe because of recreational browsing. And that recreational browsing and the inherent security risks in that drive companies to respond and apply all of these security measures. Now, my question for you is, should those security measures still be in place for connectivity from users to Office 365? So let's open that up a little bit. So I'm going to go back in time. Who was here for the dawn of time? 1, 2, 3. Who was here for when the internet started? Okay, enterprise customers, for a long, long time, large companies would not have any internet connectivity. And I'm sure everyone in this room has seen some company that started with no internet connectivity. There's still companies around there today, right? Anyone not seen that? Call you out? No? Or those people aren't listening. Anyway, so a long time ago, we had maybe the 1990s, I don't know if I got my dates right, but we've got disconnected internet policy. There's no internet connectivity, and all my enterprise data, my compute is running inside of my enterprise WAN. So these were the times where RFC 1918 didn't matter. You just used any IP address you wanted because it was all internal, and we were all good, right? There's no security because there's no one able to connect into our systems. In order to hack our systems, you had to be on premises in the building. Okay, so let's move forward a bit. 2000s, internet growth, lots of internet connectivity for companies. People are experimenting with the internet, trying to get business value. What is social enterprise? All this kind of stuff is coming up. There's a bunch of recreational web browsing on the internet as well. Companies respond, there's a risk, I got to put some security on this. Typically I've got a proxy service, a cache, a firewall, a router, reasonable amount of security devices, still no security on my enterprise data. Move on to 2005, we've got lots of network security intrusions, lots of problems with internet security, exploits, things going on, people stealing data. It continues today, and we still have no security on enterprise data inside of the organization. But because of those issues with internet connectivity and the security risks, lots of new devices coming up and are being added at that point. So now, this same company, my imaginary company that I've been following along, deploys Office 365, and at their internet perimeter security, they've got their intrusion inspection devices, their data loss prevention devices, all of these kind of things are there. What kind of security should they have for their enterprise data? Their enterprise data now being in Office 365, should they continue with no network security that they had from days gone by when they had it on premises? Everyone thinks they should have no internet security, no network security. So the other option is, should they use exactly the same network security that they use for random internet connectivity? All right? So I don't think either of those really works. I think what we really need is we need to look at the risks associated with this connectivity and see how are those risks the same or different to risks with connecting to internet endpoints, internet sites, and then apply appropriate security as needed for that. Some things to consider. Part of that appropriate security is all of this traffic is encrypted. It connects to Microsoft data centers. You have a contract with Microsoft. You're a customer of Microsoft. You have the ability to ask questions of Microsoft and get information about Microsoft security. We have a lot of Office 365 security features, a lot of them documented on the Office 365 Trust Center. You can actually get a secure tour of a Microsoft data center, take a look at some of the security firsthand. Lots of things in there. So my advice, review the risks that you have with connectivity and don't just apply the same security that you have either for your on-premises servers or for your internet connectivity. And we'll talk more about this as we get through, but I want to just look at, take a quick moment to look at some of the variety of different types of security that we have in Office 365. We have data loss prevention in Exchange for email and also in SharePoint. We have, and I hope you're using, multi-factor authentication for sign-on. If you're not using it for your users, please use it for your administrators. There's no charge to use it for Office 365 administrators. We have antivirus built in. And advanced threat protection, which is for email and monitoring of email, replacing suspicious links with validated links that we can go and use a detonation chamber to monitor attachments that we have. We use that for attachments and for links that are in those emails. Just a ton of stuff which I bet your network security people aren't familiar with. Looking at what we have in terms of security, monitorability, and just general features for ensuring compliance inside of Office 365, built at the application layer, can help mitigate a lot of those risks that we have with connectivity from users into their data. And this is part of the move from securing just the network to securing users, securing their devices, and securing the data. These features help secure the data, which is part of Office 365. So out of this, we would recommend that you use Office 365 security for Office 365 traffic. And this is principle number 4. So identifying Office 365 traffic from your users and then bypassing any unnecessary security devices which may slow down or impede or modify that traffic before it gets to Office 365. We still recommend having security devices on your network. It's absolutely the case that you have to look through what risks you're open to, how you address that with Office 365 security, how you address that with specific networking devices. At a minimum, you're going to have a firewall on there for that traffic. At a minimum, you're going to have some kind of device that identifies Office 365 traffic versus other traffic. So it's not to say that you should remove all security from your network, but review, take a look. And be aware that by adding network security, there's going to be a performance trade-off on user experience with Office 365 for that connectivity. All right, so we've talked about 4 connectivity principles so far in the first part of this talk. Number 1, identify Office 365 traffic. We have this page with URLs and IP addresses on. We're working on improving how we publish this. Number 2 is egress Office 365 data as close to the user as possible, and make sure that you also do the DNS lookup as close to the user as you can. Remember, this doesn't have to be inside of the same building as the user, although, ideally, you'd do this egress as close to the user's application as possible. I don't know, on the same machine. But whatever you can get away with is, with the worst case being a single egress point in the world. Number 3, avoid these network hairpins. I talked about 2 kinds of network hairpins. One that goes all the way across the enterprise network to a single egress point. One that goes out across the internet to a IaaS-hosted network provider and then back to Microsoft's front end. Number 4, assess bypassing proxy servers, traffic inspection devices, and any other devices that duplicate or provide for risks that are not present in Office 365 traffic. All right. So that's the first part of our talk. The second part of our talk is going through some practical advice about this connectivity. And I have the first section, which is on bandwidth planning. A lot of people ask about bandwidth planning, and I'm going to talk about this just for a few minutes. Bandwidth planning is one of those things that it's hard, and it seems like it should be easy. And when you first look at adding Office 365 to your environment, you're looking for that obvious, easy answer. How much bandwidth does Office 365 require me to add to my network? It sort of makes sense that one user will use 1 unit of bandwidth, and then I can multiply by the number of users I have at each site, and then I can get a bandwidth number that's required for each of my sites, and I can purchase bandwidth and availability, right? I mean, it works that way at home. I just want to watch one network video one video on a random cloud video provider at a time, and I know how much bandwidth that takes, and so I can multiply that by the number of people I have in my house, and that's how much bandwidth I need. So Office 365 traffic very much depends on the usage that users are making. How much usage are they making of Office 365? Do they have email? Do you have an email culture so that there's 300 emails going out from every user every day? Do you not? Do you use attachments instead of SharePoint? Are you currently onboarding to SharePoint, onboarding to Exchange Online? A lot of these things can make a big difference to the amount of bandwidth. And so we have some guidance around planning for your bandwidth, which starts with knowing the amount of bandwidth that you have available on your circuits today. We often call this headroom because as you fill up the pipe, there's headroom where you can breathe still in the pipe. And the closer that headroom gets to the top of the pipe, the less headroom you have available to breathe. And the more likely you're going to hit congestion on those networks. Congestion means that network transmits are going to fail. They're going to have to retry. This increases the congestion, and all of these retries increase the latency for a successful packet getting from one end to the other. So you want to know how much available headroom you have on all your circuits and be monitoring this. And so we recommend when looking at Office 365, you explicitly monitor how much bandwidth is eaten up in that headroom when you add users. So maybe you do a pilot with 25 users and you want to know how much bandwidth did those 25 users take up. It's likely that the rest of the users in your organization are going to have similar usage requirements to the first 25 who onboarded. Now maybe it's not going to be exact, but it's more likely than if I tell you the bandwidth utilization for another customer. If you use the same users in a specific environment, then it's more likely you can use that extrapolation and then figure that number of amount of bandwidth used per user and multiply that out and use that as a way of starting out. The next way that I really want to talk about for identifying bandwidth usage is to work with your network providers, work with your telcos, and get flexibility. Make sure that when you provision connectivity into offices, you're planning for 3, 4, 5 years out. What kind of growth am I going to get? Can I make sure that there's an extra pair of fibers connecting into that building so that I can pay for them in the future and increase my network bandwidth allowance should I need that to happen? And then all you've got to do is monitor that bandwidth, and when it goes up, add on to that bandwidth that you're procuring from the network provider. Bandwidth is cheap compared to the impacts of not having enough, or the other ways that you have of reducing bandwidth that users use. So make sure that you have enough bandwidth and identify it. Now, we have some spreadsheets that are available for calculating out the amount of bandwidth for our workloads. We have that for Exchange and for Skype. We generally would only recommend those for small deployments, so maybe do those for your 25 user pilot, but not for your 10,000 user deployment. You're going to need to do some more monitoring before that, purely for the reason that those spreadsheets rely on you entering some data about your user population's usage of the workloads, and then they do the math, they multiply out. And so they're only going to be as good as that data that you enter in about the usage, and that's really hard to do. So use those for pilots, use those for small scale. If you need to limit the amount of bandwidth, OneDrive for Business actually has a bandwidth limit sync that you can specify the amount of bandwidth that each user uses. A totally other way of doing this bandwidth planning is to look at some of the high watermarks. I call them high watermarks. Microsoft IT has a published amount of per user bandwidth that Microsoft uses in Microsoft Office buildings worldwide. It's 400 kilobits per second. It's enormous. It's a huge amount of bandwidth. But I have to say that as a Microsoft employee, we have fabulous network connectivity in our offices. So that would be a high watermark if you want to look at that. Gartner also have a recommendation of bandwidth for use with Office 365. This is part of a consulting service that Gartner provides, so you'd want to talk to them about that. And as with all of bandwidth planning, there is always consulting involved in looking into what is required in your specific need. And so my top line advice is going to be to pilot, measure, understand your bandwidth usage, your headroom available, and then to make sure you've got as much flexibility as you can to be able to increase as usage increases. One thing we know for sure, when people start using Office 365, their usage goes up. When people start using OneDrive for Business, they put more in it. We have enormous amounts of data storage we provide per user, and as users start to make use of that, their bandwidth usage goes up naturally. So some quick other factors to consider. Exchange, you can look at your on-premises connectivity, monitor that, and use that as a baseline for moving to the cloud. You should consider SMTP if you run that on-premises. Things like Azure AD are very minimal in the amount of traffic, so you can ignore those. I've got some other pieces of advice on the slide. You can take these away. We actually have more guidance that drills deeper into this at our website. Our short link is aka.ms/tune, that you can take a look at some more guidance for these individual workloads. So to summarize bandwidth planning, what we're looking at is measure how much your usage is today. You can get this off routers, you can get it from SNMP, you can get it off client logs. There are even third-party pieces of software you can run on PCs to monitor bandwidth for your users over a period of time, and you can use that. Keep those records and monitor those over time, and that will help you to be able to calculate the expected usage per user. Do a 3-year plan for as you're going to deploy, and make sure you have a great plan for bandwidth going forward. So quick hints, I've got that 400 kbits per second, which is what MSIT use. It's way more than an Office 365 customer would need. Bear in mind that it's not just for Office 365, it's for everything Microsoft employees do with connectivity out of those offices. So it's pretty all up. We're also extremely heavy users of Office 365 and data in Microsoft offices. But that's a case study that MSIT have published you can take a look at. And then calculating out from the spreadsheets and moving forward. One final word on headroom is that headroom is important. If you don't know what your headroom is on your circuits, go find it out. If you've got 0 headroom or you're not measuring headroom, you can expect to have congestion because of collisions in that traffic. most networks work on a collision detect and avoidance scheme, which means there's no collision, there's no grabbing the token when I want to transmit. I just transmit. If I happen to collide with someone else transmitting, then we both lose out and we have to back off. There's an exponential back off, and then we transmit again and hope that the other guy didn't transmit at the same time. This seems really flaky. In most cases it works. If you're over about 80% bandwidth usage on any given random circuit, typically this is for UTP, but it applies for other types of network as well, then you're going to start to see those collisions. And collisions beget collisions. As you get more of them, there's more transmits. So 20% is a good, solid amount of headroom to avoid collisions, to know that you're likely to get consistent latency across your network link. And 50% is conservative. Another reason why 50% is a good number is because 50% aligns with using HA for your network connection rather than DR. If you go with the philosophy of HA versus DR for your network link, what that means is you've got two network links in two geographically dispersed locations. They're both the same amount of bandwidth, and they're both equal to the amount of bandwidth you need. Now, you share them active-active, and so at any given point in time, you're only using 50% of your bandwidth. So think what happens when one of those circuits goes out. Users are not impacted. You've got high availability, and your circuit goes out, someone digs it up, whatever. You don't have to go and inform your users. They're still connected. You go and fix the circuit when you need to, and all is well. You have no disaster recovery requirement because you've provisioned this ahead. So that gives you the benefit for high availability. It also gives you a benefit for performance because you're never going to see collisions on a network circuit that, well, not never, but never say never, but you're unlikely to see collisions on a network circuit that's only 50% used. All right. That's enough about bandwidth management, and that's enough for me.
Okay, for the rest of the talk, I'm going to walk you through your enterprise connectivity options, what we see customers using to connect to the service. And I'll try and thread through how those principles that Paul talked about apply to each scenario. In essence, we've got three main connectivity options to Office 365. On the top there, you can see a connection through an on-premises proxy. I would say, in my experience, there's a pretty high level of percentage of customers who use this model. It's the traditional connectivity model to the internet. So naturally, they look at whether internet or traffic to Office 365 can traverse this equipment. So in the middle there, we have our direct model, which is the same as if you're sat here connecting to Office 365 or at your home, where just a NAT is done on the edge of the network as it passes through. Both of those models go through the public internet to meet the Microsoft Global Network that Paul talked about. And we also talked about that global network in much more detail in the talk we had on Tuesday. There's a link at the end of the session to that if you want to dig into that a bit more. Now, the third option at the bottom there is ExpressRoute, essentially a bypass of that internet leg to connect to Microsoft's global network for a subset of your traffic. So if you're an enterprise customer using ExpressRoute for Office 365, you'll still need one of those two top options to connect. And hopefully you're not a customer that has all three of those options because your routing is going to be incredibly complex. So let's walk through those three models and we'll look at the pros and cons of each and the challenges that they face and what we're doing to try and help those challenges. So first off, I suspect most of you know what a proxy is. A device sits at the edge of the network and connects to an external source on behalf of the user. In terms of most connections that we see, it's a regular forwarding proxy where the client asks the proxy on its behalf to connect to a service. So the client knows the proxy's there and it's its job to connect to the resource. So we end up with two TCP sessions, one client to proxy, one proxy through to the service. The other types would be a transparent proxy where the client has no idea that it's there and that traffic's just picked up and put through the proxy on the way out. Or a reverse proxy where we deal with inbound connections to the customer. So there's a large list of pros here, and this is why a lot of customers use them. Very easy to configure to get Office 365 connected. You just get your client, anything you need to go to Office 365, go to the proxy. Pretty simple. It's often the existing connection method, as I said. So therefore, there's very little work needs to be done to get the connections through there. A small number of IP addresses for clients to direct traffic to. As Paul alluded to earlier on, we have a large list of URLs and IPs to connect the service to, which can be a challenge for some customers. When you have an explicit proxy, we just have the IP address of the proxy array to connect to. And the same goes for the ports. We only need to connect to the port that the proxy is listening to. No need to route external IP addresses on the corporate network. This can be a challenge for some customers, or they don't want to do it at all. So again, because the client's talking to the internal IP address of the proxy, it solves that problem. And external DNS resolution. If we're going to connect direct, the client needs to find out the public IP address of the endpoint we're connecting to. With a proxy, it doesn't, because the proxy is going to do that on behalf of the client. And it gives us a logical barrier between the secure corporate network and the wide world. So we can do monitoring, auditing, security scanning at the edge very easily. And also, another benefit I'm seeing is management can be offloaded to a partner here. We can talk to a cloud proxy provider to deliver that control and management, or a third party to deliver that proxy on premises. So there's a lot of cons there and reasons why you would look at this as your connectivity model. But equally, there's also a large list of cons. And when I'm talking here, I'm referring to your standard internet proxy that you know and maybe not love. They often don't scale to meet the demands of SaaS services without very large upgrade costs. If we just think about the traffic and the change in the way that the traffic usage has gone when we move to the cloud, general internet proxy devices are designed to go and get a resource. So a client goes for a web page, gets the web page, then we're done. The resources, the ports, the memory, processing is all returned to the pool for the next connection. When you think about SaaS services, they're very high volume, and a lot of them will sit there all day going through the proxy and not release those resources back. So they're not really designed with SaaS services in mind, because that behavior is very different from what they're often designed for. Another issue we see is around Skype for Business. Skype loves to use UDP because it's the most performant protocol for it to deliver high-quality calls and meetings. But when we use an on-premises proxy, we're often forced to use TCP because those devices don't support UDP, or they're not configured to do so. So Skype's then forced to use TCP. We've got to deliver every packet in turn, which we don't in UDP. If things get out of order or we drop packets, it doesn't matter. Skype can fill in the gaps. Not so with TCP. So because we've got those two TCP connections as well, then there can be changes in the way that the client intended to connect to the service, because it's actually the proxy that's connecting. We see quite a lot of performance issues caused by that. The end result is often, if we're putting traffic through on-premises proxies that were designed and scaled for a different age, then we're going to likely see call problems and performance problems. So we know customers, as I say, there's a big list of pros there and why customers want to use proxies. So here's some advice around if you have to use proxies, then ensure they're scaled up to cope with SaaS services in terms of what I was just saying around the connection count and the amounts of load that goes through there. Try and avoid the hub and spoke model of centralized proxies. Paul alluded to it before around, we might have one in the UK that's used for all our UK sites. That's fine. But what we don't want to do really is have one in Europe for our 50 sites in Europe where they have to have that long backhaul to that location to go back out again, doing that hairpin that we saw on the principal slide. So, if you need to do this, evaluate what's here now, not just buying more racks of servers to replicate your existing infrastructure. Are there better options out there? Cloud proxy providers who do that scaling and management for you, or there are other vendors who have got proxies that are designed better to work with the modern age. So have a look at them, reassess whether your policy around proxying that was for yesterday is still applicable for today. Try and avoid unnecessary packet inspection. I'll dig into that a little bit in a few slides. and ensure all settings are checked and optimized. We've got a lot of the common issues linked off the URL Paul gave to you earlier on. And one of the best things you can do if a proxy is required is look about whether you can offload key Office endpoints. And I'll talk now about what we mean by that, because this is a work in progress. Traditionally, we've said to customers, bypass proxies for your Microsoft IP addresses, or your Microsoft URLs rather, because that gives you that performant connection. You can ensure that that load that we talked about, which causes problems, is bypassing those proxies, and therefore we can deliver them performantly. But what we've been looking into here is whether there's a smaller list of URLs which are critical for the service, which are causing that problem that you can look into. So what we advise you to do is look at the URL and IP page and identify and differentiate the Office 365 traffic that really is core to the connectivity, and optimize the ones that deliver high load, high transaction, and latency sensitive traffic. So to connect to Office 365, you've got a whole array of endpoints there. Some of those live on Microsoft's infrastructure, some don't. So our advice has always been around CDNs and other auxiliary services. By all means, put them through the proxy, because one, we can't provide IPs for them, and two, they generally don't require high load, and they're not going to cause problems. What we've been looking into with some of our partners and also within our own data centers is to figure out, okay, which of the Microsoft endpoints are actually causing this problem? Is it all of them or a small subset? And what we've found out is that roughly 95% of network demands are delivered by a small number of URLs. We're currently just working to finalize that list and working with different workloads to make sure we've got everything that is required to bypass a proxy here. But I think in the near future, we'll be able to give you a smaller list of IPs, of URLs rather, that you can concentrate on to bypass, and anything else we can treat like a CDN and send by your standard proxy. And for my thinking around this is that we can, when we've got that smaller defined list of URLs, rather than the probably 100 or so Microsoft URLs that we publish, is that we can easier map the security elements of the service that we deliver in the application layer that Paul mentioned into those URLs. And then we can have that discussion with the security teams about bypassing proxies much easier. So when you've got a traditional proxy, you deal with internet-bound traffic on the left side here. We don't know where it is. We don't know what's coming in or out. So therefore, we do SSL inspection, and we treat it, quite rightly, like something that's going to attack our system. But that carries cost and complexity and adds latency. If we're connecting to an on-premises server, then that will be over at the right-hand side of that slide. We can verifiably trust that application because we own it and we manage it. So what we hope is that Office 365 sits somewhere in between those 2 points. Microsoft owns those servers, we manage them, we patch them, you've trusted them enough to put your data in there. So do we need to then apply the same security policies that we do to untrusted internet sites to those Office 365 endpoints? So I think with that smaller list, we can work through the delivered security benefits in the application. So DLP, we can take outlook.office365.com. That is by far and away the highest volume URL that we see. And then we can look, does EOP, does ATP, does DLP cover what we're doing in the proxy? And therefore, we don't need to do that at the network edge where it's going to cause a bottleneck. So moving on to the direct connection model. Essentially, you're just natting the traffic as it goes through. May change the source port, but it's a pretty low volume, low intensity operation. So often this isn't going to cause a bottleneck like a proxy has to do to repackage that data into a new session. We don't have to set up a new TCP session to do that. So the pros of this, we often can better utilize UDP to do this, so Skype can work at its best. As I say, those devices aren't interfering with the payload as they pass through, so there's less chance of a bottleneck on them. And because we don't have to buy expensive infrastructure to do all the break and inspect, then for a lot of customers, it allows them to do a local egress to meet that principle we talked about before of getting that traffic onto Microsoft's global network as quickly as possible. But there are a list of cons to this. We've got a large list of IPs, and they change very often. So management has to be done to make sure that that list is up to date. And that can be a challenge for a large enterprise. If you miss an IP range off that we've added, then that can cause connectivity issues to your user. Routing to the appropriate egress needs to be managed internally on the network. So with a proxy, we just connect into the internal IP address of the proxy. Not so with a direct connection. And we require external DNS resolution. Again, could be a challenge if a company doesn't generally do that. Those devices still need scaling, though. Those connections that Outlook makes, it might make 5, 6, up to 10 connections and sit there all day with them, as I say. So those devices still have that same challenge around being able to cope with that. But because they're generally doing a lower intensity work on that traffic, then the scaling tends to be less than what's required with an on-premises proxy. So Paul's just going to talk to you very quickly about work we're doing to help customers with those cons there, to try and help smooth things over in terms of delivering that.
All right, so I sort of hinted at this before, but we are working on the publishing of that IP and URL information where we can automate that and we can improve the change management that we provide for you, the information that we share when there are updates, and get notification systems available to you. So we're working on that now, making sure that it's easier to identify Office 365 traffic on your network so that you can take advantage of some of our recommendations and allow traffic through and then optimize traffic. As Paul's been saying, there's probably a small number of endpoints that really are critical and need optimized. So being worked on today. Love to have your feedback. The current URL and IP page has a feedback link, so that would be a great place to get that. But do expect great things from us coming up. Thank you.
Yeah, the URL and IP page, as Paul says, is a feedback loop at the bottom of there, and we do look at everything that comes through there. So if you're having particular challenges, let us know through that, and we'll certainly look at them when we're building this solution. So let's look at the elephant in the room, shall we say. Quick show of hands, who's using ExpressRoute for Office 365? 3. And who's spoken to one of us about this with challenges? Oh, a couple of you, maybe.
3.
So ExpressRoute is our third option. Private peering with Microsoft's global network. It's essentially an extension of your managed network onto the edge of Microsoft's global network for the endpoints that we provide over there. Simply a routing override from the internet path. You're connecting to exactly the same endpoints as if you took the internet path, just a different way to get there. And essentially it looks like this, because some of those endpoints that we mentioned before, CDNs, CRLs, DNS lookups, live out on the internet. They don't live on Microsoft's infrastructure. So the public internet connection is still critical for ExpressRoute to work. If you don't have an internet connection, if you're DDoSed, if you have an outage, you'll pretty much instantly see that you've got issues with Office 365. So it's still a critical piece of the connectivity. So we're not replacing the internet here and the challenges with that with ExpressRoute. There are many pros to the connectivity. We can deliver 99.95% SLA for availability. We can deliver predictable performance. And notice the word there isn't better, because it often isn't. We have about, what was the number of internet peering locations we have globally? A large number of internet peering locations. I think it was about 38 countries and about 150 peering locations. We have a much smaller number of ExpressRoute locations. So sometimes the latency is actually higher to connect to ExpressRoute than it would from a local egress via the internet. This can deliver better QoS for Skype for Business, which can be a driver for some customers. And other customers have a regulatory requirement for direct networking for traffic. HIPAA, for example, is one of them that stipulates that. But you can see there is a large list of cons here. As I mentioned, you still need internet connectivity, so it doesn't do away with that as a requirement for the service. Often, when we've optimized the internet connectivity model, internet may well give similar or better performance. ExpressRoute also tends to encourage that hub and spoke model that I mentioned before with proxies, that it's an expensive investment and it encourages traffic to come to that to utilize. So again, it can actually make things worse in many cases. There is a much higher cost in most cases of implementation, usage, and maintenance. The real kicker is the complexity that adds to your management. In essence, moving to the cloud, we want it to be as simple as possible and with a low enough maintenance that you can concentrate on other things, that the SaaS service is delivering things for you. But with ExpressRoute, it adds a massive layer of complication, and that's often the thing that customers maybe aren't aware of, and we try and talk to them now before ExpressRoute is actually used for them, to make sure that that complexity is understood and the benefits that it will and won't deliver are fully understood, so the enterprise can make an informed decision about what's right for them. There's a very high risk of connectivity problems if you get a single thing wrong with ExpressRoute as well, causing an outage, and we don't want that any more than our customers do. You still need to apply security to the circuit. You can't treat it as connecting to your own data center. So in essence, Microsoft has an approval process now for Microsoft peering over ExpressRoute. And that is, as I say, to ensure that we can give the customers the information to make an informed decision about what's right for their enterprise. And often, ExpressRoute is not the right thing for them. So, moving on from those three options, we've chosen our option. We know the pros and cons. We've chosen what's best for our enterprise. But how do I choose where to egress? So this isn't an easy answer. It depends on every customer and where their locations are, where their facilities are, where their network connectivity is. So it relies on data. We look at data to figure out where is sensible for this particular egress. Just going to move on rather than talk. I'll talk over this slide to give you a visual example of how we would work on this. This is a screenshot of the USA with Microsoft's global network overlaid over the top of it. The blue dots being those peering points I mentioned, where internet-bound traffic, or Microsoft-bound traffic rather, over the internet comes onto Microsoft's global network. So we have Contoso here, who have a site over on the West Coast, their head office linked into Chicago, and one out in the Atlantic for tax purposes, that is connected into New York. The yellow lines from each site indicates a local network egress, the red line being the WAN. In this state, this is the optimal connectivity model for the enterprise. They've got local egress in all three locations. The traffic is very quickly onto Microsoft's global network, and therefore we can meet those principles that we talked about before. However, in this example, let's say the head office in Chicago, they want ExpressRoute for whatever reason. So now we put that ExpressRoute circuit on. What happens to the traffic when it goes through that ExpressRoute circuit when we think about our remote sites? So San Francisco there. Once we put ExpressRoute in, are we going to use our WAN to take that traffic through Chicago and then onto the endpoint? And you'll notice there the cloud moved because your data in SaaS services like Office 365 isn't in a place. We shouldn't design our networking to where we think our data is because it's in many places and that endpoint moves on a regular basis. So in this instance, okay, it might work fine, but for another endpoint or in a split second, that endpoint could be over on the West Coast. So we think of our traffic flow from San Francisco here when we're using the ExpressRoute circuit. We have to now use the WAN to come to Chicago, into Microsoft's network, across the US again, and then back on the reverse path. That's not really optimal. For New York, okay, that's fine. If our WAN can take that traffic into Chicago very quickly, then there's very little problem there. So what's the solution? We'd look at that in terms of data, running the Skype network assessment tool that we provide and we talked about in the other session, looking at latency and other factors. Maybe San Francisco warrants a secondary ExpressRoute circuit, gives us a failover model should one of those circuits go down. Or we can have a split model. We don't have to use ExpressRoute for all of these sites, so San Francisco can continue to use its internet egress, and the New York office can use the ExpressRoute circuit as well as the Chicago office. Okay, and we're just going to wrap up talking about inbound traffic here. Paul, do you want to do this bit? Or?
Yeah, sure. Well, let's talk about it. So we've talked throughout this whole session about outbound connectivity from a client, a user, to Office 365. And of course, you all know that TCP is a two-way protocol. There's a request and a response. You've got the SYN and the ACK, all that kind of stuff. So there is traffic coming back, but also in Office 365, in some scenarios, customers will have servers running on premises that Microsoft and Office 365 servers need to connect to. So we think about those differently, and we talk about those as inbound traffic, that is inbound to the customer. So the first thing to know about these is they're all optional. You don't have to have any inbound traffic onto your network from Office 365 in order to set up Office 365. None of them are necessary for full and productive use of Office 365. Having said that, lots of large customers have inbound traffic. In fact, almost all of the large customers that I work with, probably that you do as well, have some kind of inbound traffic that they've decided to implement. And some examples of this traffic, SMTP, if you want to run your MX endpoint for email being received on premises, possibly because you're doing something with that email before passing it to Office 365, or because you have hybrid exchange, you might need to receive SMTP traffic on premises. Federated authentication, typically the 90% case is Active Directory Federation services, but there are a variety of other identity providers. These run on premises, and Office 365 has to connect into those in order to ensure that users are authenticated to get keys, tokens, etc. Hybrid workloads are another key use of inbound connectivity. We've got hybrid exchange, where you have exchange servers on premises and in the cloud. We've got hybrid SharePoint scenarios, where you again got SharePoint servers on premises working with servers in the cloud. And hybrid Skype for Business, where you've got servers on premises again and again. The pattern is that you're connecting from Office 365, from the cloud, onto those on-premises servers.
And the inbound flow is often one of the complexities that we have to deal with ExpressRoute. If we take the ADFS example that Paul mentioned, you'll want to expose that element to the internet for your users to be able to hit it when they're out on the road and customer sites and so on, which also means Microsoft will hit that node over the internet. What happens if we turn on ExpressRoute without doing our network planning? We just add the peering, the IP addresses come in via BGP. Now Microsoft comes in over the internet to connect to that ADFS server, and if we're not correctly dealing with that traffic, it can find its way back via the ExpressRoute circuit. So what's the solution? Because that will break ADFS in a split second. What's the solution? We could move it over so it's only exposed over ExpressRoute, but then we've got a challenge. Our users that are out on customer sites can't hit that endpoint unless they're on a corporate network. So we force a VPN tunnel solution, which then causes that hairpin problem that we mentioned before. So this is just one example of how inbound flows need to be carefully considered, especially when we're looking in terms of ExpressRoute.
My recommendation for the inbound traffic that you're looking at, it is all optional. That doesn't mean you shouldn't do it, but identify one by one what those inbound services are. Each of them is going to be identified by a URL which you control in the DNS, the customer controls, specific IP addresses which Office 365 will connect to. Identify each service. Understand the network flows that are going to happen for that service, and then they're going to come on premises, whether they go over ExpressRoute or over the internet, or for some reason you're looking at them going over both. And then work through making sure that the routing is accurate for each one of them independently. If you make them all work individually, they should all work as a group. But there is a whole lot of extra work in making sure that that happens.
Okay. So to wrap up, We'll just have a look at these principles again, and hopefully they're a bit clearer about how they apply to your connectivity. If we could identify the endpoints that are really key to us, and as I say, we're doing some work to help assist you in this area, can we treat them differently to reduce the complexity on your side, the cost on your side, and deliver that high quality performance that we require to deliver the service as if it's on premises? Egress that data as close as possible to the user with matching DNS resolution. Let Microsoft do the backhaul. Let us do the optimization. There was a talk earlier on in the week that we did on Tuesday. We talked about how Exchange and SharePoint and Skype for Business connections work very differently. But if you do local egress, we can provide optimizations for all three of those workloads locally. Avoid network hairpins where possible. Kind of feeds on from the second one, in that we want your traffic on our network as quickly as possible. So not going back through a different country to come out again, because that's going to impact our user performance. And assess those URLs that we've identified in option 1, and sit down and walk through them and say, are we duplicating security at the edge of our network here? Is it required for these endpoints? And if possible, can we remove that duplication, and also the cost of doing so? And if we follow these 4 principles, we're confident in customers that we've worked with that have delivered on these, they get great quality performance with all their services. And when we change things in the back end, we add improvements. Take multi-geo, which was announced this week. If you have local egress, you can instantly take that on board if you sign up for it. You can move your data closer to your user because their network egress is local to them. If their network egress is in the USA and they're based in EMEA, then there's no point moving their data closer to them because their network egress is over in the USA as well. So by following these, I think it abstracts you from the change that happens in the cloud and enables you to take on board the performance benefits that we can deliver from the edge of the network. And with that, I promised we'd list the sessions that I thought were relevant. There are some Skype sessions that talk about the benefits of the local transport media relays that they're using. And Paul and I and Kostya and Jeff did some sessions this week that would talk about different elements of what we've talked about today in more detail. So I'd encourage you, if you didn't manage to attend those, to have a look at them online. And with that, we have a few minutes left. If there's any questions, feel free to come and ask through the mic. Otherwise, we'll be here for a little while afterwards to answer any of your questions.
We'd also really appreciate your feedback for the session. Really helps us know what to work on next and what to plan next. We're both super passionate about network performance and network availability, and we're really keen to continue to work in this space and improve connectivity for Office 365. So all of that feedback and your eval of our session would be very appreciated as well. Yep. So thank you for coming along. Okay. We do have a question.
We have a question up here.
With regards to the Office 365 IP ranges and keeping them maintained, are there any plans to give people the ability to do a point-in-time lookup? Because one of the challenges is, depending on the appliance, you have to delta out what was added and what was subtracted. And currently, we're doing it just by maintaining a record on our side when the last time we pulled the list was. And just keeping the hard copy of the XML, because once it goes away, you can't get it back.
So one of the common questions we've had is to be able to get changes between month to month as well as the whole full list. So that is something we're looking at because we are working on updating the publishing of those right now. It's a pretty high level piece of feedback that we've had to be able to give you not only what we have today, but also the changes since last time and the changes since before that. So you can go back and maybe pass a parameter or something and get those. So you should be able to get what you're asking for out of that.
Okay. Will the format be, automatically parsable, like the XML file? Or?
Absolutely, yeah. In fact, so we're looking at formats, but certainly at least as easy to parse as XML. I'm not sure XML is the easiest format to parse. It is obviously easier to parse than the HTML that we have published in, but yeah, definitely heard that feedback as well. But thank you for raising it.
Thank you.
Seb.
Hi, it's also a question on or a feature ask on the IP and URL. Right now, we kind of have to go back and forth between the article and the XML file to define the port association with some of those workloads
Right.
for Skype for Business, for example.
Yeah.
Do you have any plan to add that inside the XML or whatever you're working on so that we only have one place to look at?
Yeah, and I heard that one as well. So specifically what we've heard is some of the attributes for the URLs and IP addresses are listed in the HTML. Why aren't they listed in the XML?
Right.
And yeah, what we'd like to do is segregate those two types of publishing. HTML is essentially what we'd want to publish for people to read and get guidance from. The data, or XML, is kind of what we want to be published for tools to read or network devices to read. So once you think about that separation, it becomes obvious that you don't have the port stuck in the HTML. They would move over to the data.
Right. Even if we have two tables, we can do like a join or something. That would be great. And then on the tooling side, we also would really appreciate a tool where we can actually test out that our network team opens a port and FQDN that we ask them to, because we have many security devices, and after we submitted the change request and we did the network assessment with you guys, we ended up finding out half of the device were not configured correctly.
So there's a tool called PSPing, a Microsoft tool, which you can give it a URL and a port, and it will make a connection to it. So obviously that relies on a direct connection. But if that's what you've got in place and you want to check that the required port and URL, you could easily script. I mean, I'm not saying it'd be simple to go through, but I publish a pack file every month with all the URLs in a kind of consolidated form.
Oh, thank you.
That's linked off the URL and IP page as well, until we get this new solution in place. So that has a list of all the URLs required for the service. The only thing you would have to do, probably manually for now, is map the port to that.
Right.
But then you could script that through a PSPing.
Yeah, so it goes back to my first question, because I can script it. It's just like right now, it's a lot of manual effort to get those two together. But if you guys ever do a tool, that'd be great.
It's something I can look at if I get time to build one and publish it.
Thank you.
Certainly. Thank you. Okay.
Hey, while we're taking questions, I wanted to point out we have buttons to give away. They're up on the stage here. We have SharePoint buttons, Exchange buttons, Teams buttons, Skype buttons. You guys all want to come forward and get buttons, right? We'd love to give away some buttons.
Great session, guys. I have a question way back here.
Sorry, can't see you in the
I
lights.
got one more. It's pretty easy.
Where is
so
that
you
voice?
mentioned right here.
Got it.
So you mentioned the XML file and applications and tools using it. Do web proxies and certain firewalls go back and read that file to keep the rules up to date?
There are some, yes, and Paul's working on a solution where that should hopefully become easier with more partners being able to pull that data in.
Yeah, absolutely. And I'll make a plug. If you're working with a particular firewall vendor, ask them about this and send me feedback as well, because we'd love to have all those vendors pull this data directly so that you just have to say, works with Office 365, check the box,
Yeah, I've
and they
seen
pull
that.
down
I've
the
seen
data.
in their setup in the web proxy and on the
Right.
firewall side, Palo Alto and McAfee.
Yeah. And there's some cloud proxy vendors that will do exactly that for you already as well.
Okay.
Okay, thank you. We better wrap up in terms of time, but we'll be here for questions afterwards for a while, if that's okay. Okay, thank you everyone for coming. Appreciate it.
Thank you.